Hello. Imagine that you watch some people playing poker and you don't know, what are the rules of the game? You see that some cards are given to players, some cards are on the table, then players do some actions and one of them wins. Would it possible for you to be able to play poker without reading the rules? Imagine that you have records of billions of games and your task is to be able to play the game. You have at least 3 possible approaches. 1. You can try to guess some formulas that calculate probabilities of winning and losing depending on the cards you have. Check those formulas using the past games and say that you understand the game now, because with some accuracy you can predict the result. 2. You can try to build statistics of whether the cards you have are enough to win and use that statistics to make decisions when you play. 3. You can try to guess the original rules of poker. In this case you would have to guess that there are specific combinations of cards that let you win, that cards have order, that they are divided into suits, colors. Of course when you use approaches 1 and 2 you can use logic as well. Nobody can forbidden you to use order of card as a priority in formula. Which way is better? I can't tell that. But I think only the third way gives you the real understanding of the game process and really answers the question why. Having the rules of poker we can build better statistics and formulas if we need to. What all of this has to do with physics and universe? I believe that we are playing some kind of a game ourselves. That this game has rules and we can try to find those rules. Find the rules of nature. I believe that the laws of nature, laws of physics as we know them now are the results of applying approaches 1 and 2 to the nature. In other words, I believe that physics does not describe nature, only predicts its behavior. Physics with all its laws, fields, principles, wave functions is only some kind of statistics of matter movement, not the rules. And there are also rules that we can find. And because physics is statistics it predicts nature as any statistics should do. But to predict does not mean to understand. You can calculate the average age of some group of people, but that does not describe any of them. Let's show an example. Let's assume we have 10,000 of men and each of them has a coin that he can toss and probabilities of heads and tails are equal for each coin. Each of men tosses a coin. If it's heads, he moves 1 step to the right. If it's tails, he does nothing. Let's assume that all of them toss a coin synchronously, at the same moment of time. And we group the amount of people by the amount of steps they make and show those amounts as a distribution. After 1 toss each of them can make either 1 step or no steps. The probabilities are equal. After 2 tosses each of them can make either no steps at all or 1 step or 2 steps. But the probabilities are different. You can make no steps only if you had heads on first toss and heads on second toss. You can make 1 step either if you had heads on the first toss and tails on the second toss or tails on the first toss and heads on the second toss. You can make 2 steps only if you had tails on the first toss and tails on the second toss. And so on. The more they toss a coin the more the set of your possible positions is closer to what is called normal distribution in statistics. Even though it seems that instead of 1 definite position they have more and more possible variants of location and their position becomes less and less predictable, if we take into account the total amount of tosses, we see that the most probable distance we pass over time appears to be closer and closer to 1/2 of the total amount of tosses. So here is a law of nature for you: if you toss a coin 1,000,000,000,000 times, you will make 500,000,000,000 steps with high accuracy. In reality the amount of steps you make will not be 500,000,000,000, but in physics it does not matter. In physics you actually never have exact predictions. Any physical law includes accuracy. For example, good accuracy could be 6 digits. For trillion it's plus or minus 500,000 steps. Any amount of steps from 499,999,500,000 to 500,500,000 would be a very good prediction for 6 digits accuracy. Would normal distribution for trillion tries fit into this interval? To say the truth, I did not check and I'm not sure if that means much. But even if it does not, We can just increase the amount of tries or decrease the accuracy and repeat what I've just said. The fact is, the more tries we have, the more accurate predictions we have from physics point of view. Why it's okay for me to speak about trillions of coin tosses? In one of my previous videos I told that if my assumptions are correct, then each photon consists of around 10 to the power of 15 discrete pieces. Link to that video is in the upper right corner now. In another video I assumed that interaction between particles in our world is when particles exchange those discrete pieces. And that causes Heisenberg's uncertainty principle. Link to that video is in the upper right corner now. So if those assumptions are correct, even 1 trillion of exchange events is only 10 to the power of 12 tries, and it would mean almost nothing for a particle that consists of 10 to the power of 15 pieces. 1 trillion of interactions will update only 1,000th part of a photon. What I want to say: if interaction consists of trillions of independent events, the result of such interaction will be always normal in some sense. Huge amount of discrete changes will turn into one result that is predictable with accuracy that is high enough. And we will call such result the law of nature. Depending on the density of matter and the direction of matter movement, distributions that can appear on the basis of normal distribution will look differently. For example, this is what I get when I simulate the matter density decrease as a square of one parameter, and initial density increase as a cube of another parameter. Please note that it's only a demonstration, intentional data manipulation. I don't state that it has any connection to the black body radiation, but I state that black body radiation distribution can appear to be a result of some hidden discrete algorithm execution. So those are independent events. But what will happen if events depend on each other? In this case, the result does not have to be normal, the distribution of events can be different. For example, using a small primitive trick that I will not describe now, I got this distribution, when some states of the system are more probable than the others. What do you see when you see this? It's a result of light passing through a slit. Physicists would say that light has wave properties, therefore we get this wave pattern, diffraction. What I see here is a distribution. Distribution of results of trillions of interaction events, which are not independent. I see this wave per my assumption is not an independent phenomena, but something similar to distribution. But instead of independent events for normal distribution, wave would be caused by sequences of dependent events, and some of them would be mutually exclusive to others. For example, kinetic and potential energy for pendulum. So per my assumption, wave is a distribution of some sequence of mutually exclusive events that cause each other. Those are my ideas on what physics really is. Radical statement. Not sure if physicists will accept it fast. But I do believe that under each physical phenomena some algorithm is hidden, and all those algorithms have one reason, one simple algorithm of matter. We can find the algorithm of interaction that leads to appearance of wave, particle behavior, electricity, magnetism, relativity, gravity, and everything the rest. I believe that we can find the rules of the game. It's harder and harder for me to believe that game without rules can even exist. I don't say that personally I will find them. No. Investigations needed, supercomputer needed. But I have some ideas on how that might work. And I show them one by one. Press subscribe if you want to know what else I have to say. Or if you want to see how physicists will react to such idea. Some of them should be angry. After we find the rules, we will be able to build the real laws of nature. Or maybe confirm or slightly correct those laws that were already found. And not only found by physicists, but also biologists, philosophers, and maybe even mathematicians. By the way, physicists often ask a question: why mathematics is so unreasonably effective in physics? So here is the possible reason. Mathematics is effective in physics because physics is a kind of mathematics. Extended statistics. Classical physics describes results of almost infinite amount of interactions. It's called expected value in statistics. Quantum physics describes results of small amount of interactions. Observer effect is some kind of a bridge between quantum and classical physics. Observation device has high density of matter and we get wave function collapse, normalization of a state. The same way distance passed normalizes in the example earlier in this video. I hope someday we will have a separate video on that. Thank you for your attention.